So to protect such I/O, so it's more critical the I/O protection in the memory, but even in the using the I/O device, it's critical to protect the such I/O. Actually, the most of I/O will be based on the instruction level. Okay, so instruction will be performed by the kernel state, the kernel mode. We have learned about the dual mode of the operating system, system level, and system mode, and the kernel mode. So the two perform to read and write the data from the I/O devices. So we go through the system code. That system code will be executed by the kernel. The mode is it working? No, not right now. Yeah, no problem. So we can use such instruction to protect the I/O. So can I use this one? Because my battery will last only the 30 minutes. Okay, so this is an overview of how to use the system code to perform the I/O. I think that this is based on what we learned in the beginning of semester. Okay, first TRAP is the software version of the intro. Okay, then perform the I/O by executing the system code, and how the output will be returned to the user based on the dual mode process. Okay. So this is the overview of the Unix Unix I/O kernel structure. Actually, the left hand side is for the user level, user process level. The user process will manage all the open file list as we have seen before, the file system structure. Then in the kernel mode, kernel will manage the two lists. One is per file, how many process are accessing. So each file and how many process, and for each the process, what is the open file list. Yeah. Nowadays, another issue is the very interesting issues, the power management. Why the power is related to the I/O device management? Because of actually the smartphone. So power is actually the big issue in any computer. The CPU consume a lot of the power. So still there are huge amount of active research how to reduce such a the power to process, to compute the instruction. So, but nowadays if you compare the development of the improvement, enhancement of the computing power with the improvement of the battery power, okay, not computing power, battery power, energy, it's actually the huge gap. Okay. If you can actually develop the battery that can last the 50% more than the current one, I think you will be richer than the Bill Gates and others. So the battery power is a big issue, especially nowadays the smartphone. So even I/O device consume a lot of such a power. So how can we reduce such the power consumption in the I/O? So that is critical. It was the power management was still is critical in the network, the sensor network. Then it's moved to the nowadays mobile device, the cell phone. Okay. So another way, for example, in the Android development, so is if the application, so even though the Android application support the multitasking, but if the one application is not used currently, then you can actually stop the processing of the any I/O operation for such a sleeping program. Then we can consume the last power. So unused component will be turned off. Something like that. Okay. So there might be more opportunity to manage the power in terms of the I/O management that will be the interesting topic. Okay, then the streams is the one of the example is Windows. Okay, how to manage the such a input and output is a kind of structure. It's a stream based from the user request and the device. Okay, so you can actually go through the several modules. It's actually the name is the abbreviation, but it indicate the kind of the mechanism of the process, like this is a stream, and by the connecting the several modules, different modules, finally read the data, then the such a read data return to the user. That is the stream, the structure, or in other words, it's called the pipeline approach. Okay. So we will end the I/O management, then move to the switch for memory. Standing on. Okay, the main memory. So as we discussed a lot at the from the beginning of the class, there are three the major components of the management issues in the operating system. One is the process management. So we have talked about how to create what is the data structure for the process, and how to manage such a process. Sometimes when we have the multiple process to access the shared data, and how can manage such a synchronization issue also up to the deadlock situation. Then in the third part, actually we skip the second part. The third part we talk about how to manage the file to keep where we can store the data. So from the file structure and file system and implementation of such a file system. So right now you are implementing portable file system for your project B. Then the last one was how to manage such an I/O. So then finally we can deal with the second important management issue in the operating system. That is the memory management. Then what is the memory? Storage, but that's different from the file or the secondary storage, right? So what is the main difference?
It's faster.
It's a faster
and small.
and smaller, which means it's expensive. Another interesting is the hollow time, which means without power it will be gone. There are different, but in general the memory. So that is the issue. So if the memory is cheap enough and the scalable, actually the memory can replace the hard disk drive, secondary storage. Unfortunately, that is not possible yet. So most of all the system nowadays utilize such a memory structure for the first primary storage. Primary storage means from the CPU it can access the data primarily from the memory. And if there's nothing in the memory, then go to the secondary storage, then move such a data into the memory. Okay. In other words, we can use such a memory as a cache purpose. So that is the main issue, to speed up the overall system power, to reduce the bottleneck of in the secondary storage. So how can we manage such a memory? We will go through such an algorithm using the memory management, the swapping. Have you ever heard about the swapping? So have you ever installed the Linux system by yourself? Okay. Then sometimes some of the Linux operating system provide the simple installation procedure. You can just click, then that's it. But when you download the kernel file and operating system, the source file, then compile the kernel and install, you need to specify some configuration parameter. One of them is you need to specify swap space. So what is a swap space? Also, in your Windows system, you can actually change the size of virtual memory. Have you ever tried? Why don't you go to the your computer and property, then you can see the size of the virtual memory. Okay, you can change it. That is actually swap. What is a swap? Swap is a change. Change what? Yes.
Swap to the secondary storage.
Secondary storage. Good guess. For what?
If you have too much memory, too much full memory.
The basic idea of the swap is, anyway, we have the memory, we have the hard disk drive, secondary storage. This one is much bigger than this one, right? So, but the CPU can access the data only the memory, right? So, if we have the unlimited enough size of memory, we don't have to worry about all of this actually. But as you mentioned, it's a small. So, for example, this one is used for process A, process B, process C. There's no more space. What about the process D? We need to swap this one with the secondary storage. So swap entire process. That is the idea of the swapping. What about the nowadays? Anyway, what happened during the swapping? It requires the process should be switched, which means it requires copy and bring another process, a lot of I/O. Okay, which means it takes a long time to swap the two processes. So it's idea, but actually nowadays we do not perform the real swapping. Instead, we still use such a virtual memory. We will see how can we utilize such a swap space for memory management. Our goal always in the memory management is to speed up the overall performance. Okay. Then anyway, we need to allocate the memory to the process. Okay. Depending on how to allocate, we have the different algorithms. Okay. Then we are going to define some data structure of this one memory, that is segmentation and pacing. So pacing is nowadays the most important, the algorithm data structure used in the memory management. From time to time, you may see the even task manager. You can see it's a total physical size, it's a kernel memory. So you can see the page, right? So page is the data structure. Okay, to manage the data in the memory. Also, there might be in and out because we anyway will have limited the memory, limited pages. So we need to use by replacing not entire program by program swapping. We can page in and out. Page level change the data. So that is called the pages. The more page, the better. The more page in and out, the better? No. The more page in and out you have, it's the less. So that is a reason there are several different the way to check whether your system has good performance or not. So one of the important thing is you can check the number of pages, I/O. Okay. For example, I have several different. This is a CentOS operating system, so Linux system, but all the other, the Linux-based operating system has the same command. For example, if we want to see the current performance of your system. Based on the I/O, you can use I/O state command. Like this one. So it shows. You can see every 2 seconds it shows some information, how many blocks are read per second, and how many blocks per write per second. Okay, it's a transaction per second, and block read, block written, and at that time what is a CPU time? So there are two, the user CPU time, system core system time is a user mode and kernel mode, and also you have the I/O and the how many, the I/O weight. Okay, so you can measure the judge whether your system is fast enough or not. Then the per device, when you have the more the hard disk drive, you can see the device level, the performance right there. It's the I/O state command. Another one is the MP3. It's a multiple processor. When you have the multiple processor, you can see the performance of your system based on the processor. Right here I have only one CPU, right? So one CPU for each CPU. What is the user time and what is the sys time? What is the I/O weight and the other, the indicator you can see. So it's almost either, because I'm not doing anything. And also you can see the memory. They're using the blame state, the command. So you can see it's a number of a process that is running. So sometimes it's 0, sometimes 1, sometimes 2, and swap space and the free space of the memory, and so how many of them are using buffer and the cache. And swap, what is the swap in and out? Almost nothing. And the I/O, how many I/Os are in the overall system, and it's the system core and the CPU information, something like that. So these three are used a lot to see the performance of the system. So page in and out is depending on the operating system, sometimes it's a little bit different, but mostly the same idea. So here, this I/O indicate page in and out of the system, not I/O device. Okay. So we will see such a page structure. Okay. In this chapter. So to understand such a memory, do not have the eraser.
Yeah, it's okay.
Okay. What about the Windows? Windows, you can use a task manager. Then there's a resource monitoring from the Windows 7. So you can use such a resource monitoring. So by the CPU and memory and hard disk drive. So most of the operating system, because these three are the main management issues in any operating system. Okay. So first we need to understand how the instruction is executed in the computer system. What is the instruction, by the way? It's the smallest unit of command, okay, to run, to command your computer, especially CPU. So in other words, the CPU can execute instruction by instruction in their data structure. So where can you get? So from the CPU would like to process such an instruction. Where can CPU find such an instruction? It's in the it's a memory. So who upload such an instruction into the memory? User execute. Okay. User start or the user share program of the user start the program. Then program that include the instruction loaded into the memory. Then CPU use the CPU scheduler or dispatcher who is the next process. Then what happens? In the CPU, once the CPU scheduler decide process A is the next one, what happens? It's a context switch. Okay. What is a context switch? It deploys all information about the current process by the selected one, including one. All register data, register information. Register, actually CPU cannot read the instruction directly from the memory. Instead, from memory, copy to the register, then read the data from register. There are different register, probably you learned in the register about the register in your microprocessor class and the assembly class. So the copy the register information regarding to the selected process by the CPU scheduler, and we fetch the instruction first. That is called the decoding. Then some of the register, okay, has some relative address of the data, okay, or register information. So such a data, if you read register 1, okay, register 1 has the address of the sometimes the data, or sometimes it refers the other, the register information, then you need to actually get the replace such an information relative the variable by the real data, that is the fetch operand. Then finally you can execute such an instruction, then such an executed. Sometimes you have the output, sometimes not. Okay? If you move I2 data, if you have the address, that address point the data, that data move to the register 1, something like that. Okay? That is the execute, and such a data will be stored in the memory. That is the one execution cycle. At the time, we need read the data, read the instruction from the memory, and the output will be stored to the memory. So it requires the memory. Then how can CPU find such information about the process, each process during the context switch, and then to execute the instruction? It has the base, the register, okay, and limit register. What is the base and limit register? First, the CPU should know where the process A is located in the memory. Okay, let's say this is a memory from A2. It's a 1 megabyte, the 1 megabyte size of memory. So this process A is loaded into this one. Okay, so let's say that is the 300K to the 400K. So CPU when after context switch, CPU has the register base. This is a base register. Base register has the data for this, and the limit register is the size offset of the process, this address for the process. Then using this base and plus the limit, base plus the limit, you can know where this process is located. Where can the CPU get such a data? There are registers. Okay, this register information will be copied during the context switch. So that is the base and the limit register. Okay, so this is the how can this will be performed. The CPU actually provide hardware to compute the logical operation. So if the CPU get the data address of the base, okay. So if this one is less than something or the out of the space, then the thread is the error. Otherwise, the plus the address of the limit, the register to the base, then check whether this is the out of memory address one. If yes, then finally read the data using base plus the base through the base plus limit. Okay. Then finally CPU can access such a data from the memory. Otherwise, it will be trapped to the operating system. Operating system recognize this address information is not valid or the correct. So that is a reason from time to time you will get the error message like the pop-up from the window. It's a memory, something the address is not found. And that is actually trapped on your program. Okay. By the way, in your program, so in source program, you will have the main command and integer I and define the such a thing. During the compilation, this source code will be changed into instruction. Okay. So in the instruction, do you use integer I or the something the double integer j, something like that? No, it has different the data type and data structure. So this should be changed. That is called address bind. Okay, you need to bind. You need to convert map such a high level, it's a symbolic address. This is called the symbolic address, and into the real address like this one. Okay, this is the address of the memory. So let's take a look at this one first. There are different types of the address format. So in your program, we are using like the integer I, the double J, or float K, something like that. After compiling, can you get the exact address? Not yet, because you don't know whether the program set of series of instruction loaded into the here or here or here. You don't know yet. This one has the relative value. In other words, offset. In your compiler know what is the default size of address and also address format of your hardware computer through the operating system. That is the reason, even though you have the same the compiler like the GCC or the CC or any other, dash will be different depending on your operating system or computer. You should have the different one. What about the Java? Java is compiled once, run anywhere. How?
Virtual machine.
Because it's running on the virtual machine. Virtual machine will take care of all difference. Okay? Then from your object file, you don't have to worry about the your hardware, the data structure like the memory and the CPU, but your virtual machine will take care. So in other words, the virtual machine will be varied depending on your operating system and system architecture. Okay, so then this one, once this process is loaded into the memory or the executed, then finally it has a physical address like this one. This is the physical address, and CPU will read this physical address to access the data or get the instruction. Then perform such a thing. So the address will be binded three different ways. So compiling time, as I said, from the symbolic address, it will be the relative address. Okay. What is a load and what is the execution? What is the difference? In other words, so this is the step, series of steps to process your program. So from the source program you can compile, you have the object file. Okay? Then there is the load time and there is the execution time. Can you read that one? So this is the load and this is the execute. So what is the difference?
Reading is only the reading the data.
What kind of data?
Instructions.
Instruction? Yes.
Necessity expected output.
Expected output
Yeah, execution.
in the execution.
But load would that just deal with the data? How to
Deload the data.
yeah.
Read the data.
Read the data. What kind of data?
Read the program into memory.
Load means that include the link. So when you compile any program, did you separate the step by step? Okay, sometimes so when you compile GCC, C program, you can make the object file. Then you can actually link. What does that mean? Link your program.
Connected
Combine with what? Other library. Sometimes usually system library. Okay, this is in purely your own code. But if you are using the printf, there should be program for the printf. It's not your program, right? So in Java you import. What about the C program? C program you should define header information only. During the link, it will linked. That is the load. Okay, it's ready to be executed. Okay. Finally, when operating system execute, then it will be loaded into memory. And at the time, there are two different links. One is the static link will be done during the load time. Another one is the dynamic linking. What is the dynamic linking? What is the difference? Link in the load time and link in the execution. You don't have to worry about such a thing in the object-oriented programming. Okay? But still, you can consider such a static link in the load time and dynamic link in the execution time. For example, printf is the system library. So it's in the io.so. So somebody already compiled it, and so you have the such a dot shared object file. So if you add this one in your object file, for example, foo.o file and link make the foo.exe file. So at this time, this is the added linked physically to this one, the foo.object file make the foo.exe. That is a load. Okay. If you want, this is not physically added, but it has only the header information only during the execution. Okay? Using this header information, you can find like the etc the lib/io dot the so file, then dynamically during the execution time, you can dynamically link. This is called dynamic link. Which one will be bigger? The foo.exe in the link during the load time, or foo.exe during the link during the execution time? Definitely this one is bigger. It's called a static library. So some critical systems actually they do not allow the shared library, dynamic link the shared library. You can include all object file. In terms of Java, include all object file, compile the make the jar file together. Okay. But usually what you are doing is you import the location of the object file that is somewhere means class underbar path. Along the class underbar path, that library object file should, as long as such a class file exists along the class path, you can dynamically read that object and execute it. That is a dynamic. That is the difference. Load time and execution time. Okay. So there are two different address space, except the symbolic address. Symbolic address is only for the user understanding perception of that variable, but we have the logical address, it's a virtual address, and also finally we should have the physical address that can be used to find the location of in the memory. Okay? So we need to manage such a logical address and physical address where? In the memory space, because the CPU can access only the memory area. So we need to manage such a mapping, logical address and physical address. So that is managed by the base register. Nowadays it's called the relocation register. Okay, so if you already took the microprocessor class, so you probably learned the 8088 or the 8086, also the 286 or to the Pentium. They use the full relocation register. Using that relocation register, you have the pointer address of the mapping table. Where is it? In the memory. Then CPU using the relocation register, for example, this is the F00, so there's a F00 in the relocation register. The CPU read this one, then find the where the mapping table exists. Then the logical address will be, if there is a logical address in the instruction, that will be mapped to the physical address. This will be accessed. For example, 0 means it's a 500 in your memory. Then you can find the data from the 500 and back to the, you can move such a data to the another register, the general purpose the register. So whenever you have the logical address, that will be added to the relocation register nowadays. Okay, then we can find the physical address from the memory. Dynamic loading means, as I explained, the dynamic linking during the execution. So some of the instruction in your program will not be loaded into the memory until they will be loaded into the memory when the instruction will be when the instruction is called. So that is called the dynamic loading. Why? To maximize the utilization of the memory space. Okay. So loading, whenever we say the loading means the use the memory space. Okay, so I already explained about the static linking, okay, during the loading time, and the dynamic linking. You can do you can use the shared library. So in C program, it's called the .so, object-oriented programming. It's the object file. So then that can be done during the execution time. Which means if you use io.so, it's a dynamic linking, then this one will be loaded into the memory just one time. Then several processes can share this one. Okay, we don't have to, but the static linking that's linked during the load time, it will occupy some memory space. Okay, but that may cause sometimes the problem of the security. If this is shared, the library has some security hole, then somebody may have put some suspicious code or whatever. It can be entire your system can be problem. So some of the critical systems only use such a set linking. then swapping. So swapping means, since we have the very limited memory space, so for available space in the memory, we can switch the process A by the new process. That is the swap in. Swap in means that we bring a swap out first. Swap out is from the memory. We can move to the secondary storage. That is a swap out. Swap in is bring another process to the memory. That is the swap in. Load out, load in. The problem?
So
Very slow. So it's not actually used in the current operating system. Okay? But such an idea is, yes.
what about if we use SSD as a second storage? That would affect the speed.
The SSD is used for what?
Persistent storage.
Actually, it's the small, okay? Right?
Not small. It's really big now.
It's
It's
smaller
okay.
than the
Yeah.
hard disk drive, the 5.2, okay?
One
So,
terabyte, right?
yes, so it's used for that. Also, it's non-volatile, okay? But still, it's expensive. So it's used for secondary storage, not the primary storage, okay? In terms of speed, it's slower than the primary memory. But it's faster than the second hard disk drive, such as the 5-inch, 5.25-inch size disk. Yes.
Is that will affect when we swap the data from the main memory to the
Mhm.
SSD?
Mhm.
Does that make difference or?
It still has the I/O, input and output. Okay, so it still has the input and output, but that's also one way to tune up your system. Somebody use such a device that require a lot of I/O, like the swap space, also temporary space. Also, temporary space used a lot for many processes. Like when you open the file is copied actually to the temporary. Also, when you connect the server remotely, actually the server side, the server program creates some temporary file on your temporary space. So you can actually use such a faster media like the SSD for such a device that require a lot of I/O. Okay, so that's one way to tune up your system. The problem is expensive than the general hard disk drive. Okay. How much is it nowadays? I used the SSD last time, the 256 gigabyte. It's several hundred bucks. So I used a used one. It's still 100 something bucks. So from eBay.
You can buy 256 now for about 50.
What?
You can buy like a Samsung SSD 256.
250.
About
256
gigabytes.
gigabyte.
Yeah, about 70, 50.
70, 80. Okay. So this is the general idea of the swapping. Not swap your wife or the husband. There's a TV program. It's a swapping. What's the name of the program? Wife swap. So it's a swap the process. Definitely it's not the efficient way because you need to context switch entire the process. So this slide showed how expensive such a context switch of the swapping during the swapping. So it's just a simple math. You can multiply. You can just apply the multiply based on the speed, like when we have the transfer speed, the 50 megabyte per second, and the 1 megabyte size of process, and swapping time. So you can compute such a swapping time. that time you need to consider the transfer time, not only just one, but also the swap in. Okay, so total swap time will be, you need to consider transfer and the swap time. What about the mobile device? Nowadays, the mobile device, so we are using the flash memory, the SD card, okay, for the storage. That's it. The swap in and out in the Android or iOS for the entire process. No, instead they keep but deactivate that process level, right? Process, okay? So that's the different thing. So main the problem of the such if we consider swapping to manage the process, keep in mind such a swapping is not use the current operating system. Okay, but that is the basic idea how to manage the memory, limited memory. In case we do not have a space, available space, so we change, replace, switch the two processes. One process in the memory, another one is in the hard disk drive. Okay, for that, the implementation we need to find the different method of the allocation of the process into the memory. So we have the different ways of the allocation. So this diagram showed how to allocate the processor. For example, the first time that we had the processor 582, but there is no more available space. We need to do the swap the process. So we take out, swap out, roll out the process 8. We have such a space. Then we can swap in the roll in the process 9, and also we have available space. So until we fit, we have the until we do not have the available space, we can swap in the more space. But if we cannot find enough space for the process 11, we need to roll out one of the disks. Okay, then there might be a hole sometimes, even though we have the available space. If we, for example, we have the hole and another hole available space, but if we have this amount of the process cannot fit. So we need to be smart. How can we make the smart? There are different algorithms. The first one is the first fit. First fit means if you can find any available space, so from the low address memory, then allocate it. That is the first fit. And best fit is because the memory space is partitioned, because you already have the swap in and out, use the memory. So this is the continuous address of the partition you can use up to this one. You are going to find the best, the whole available partition that can produce less, the whole, less available space. For example, so this is an example of the first fit. So this is the current status. So we have the 0 to 3000 memory address. This amount of memory, currently there is operating system reside on the lower memory, and we have 2 process. And there are 3 holes. The first hole has the 600 byte, and the second hole is a 600 also. Third one is a 400. The first fit is if we wanna load the program P1 into the memory. First, this one is the lowest address, the hole, so we can use this one. Okay, this is the first fit. Best fit means if we allocate this one to the here, so need 300, it will be 700 P1, the 300 hole, 300 available partition. Here is the same thing. It's a 300. It's a P1. This is a 300 available. However, if we allocate this one, this is the only 100 available space. So this one is called best fit. Okay. What about the worst fit? Worst fit is we are going to find that can produce largest available space. Which one will be better? Best fit or worst fit?
That's worse fit.
It depends. So worst fit is not, does not mean worst the one. Okay? Because you have the bigger size anyway. The
But if that's
The
a
chunk.
rare case, that's a rare case.
Mhm.
I mean, that's not happen so more often. It's like a rare case, right?
It's not rare case, it's your average, your policy. You need to decide, okay, how it. Also, first fit, is it worse than the other one? Sometimes you're lucky, but you don't have to worry about the what